Okay. So what are the components of a box plot? What are these indicating?
There are outliers that we can see.
No, no, I'm asking you what are these?
Oh, this is the range.
What is the range?
It's an interquartile
No, no,
range.
no. Here, what is
Yeah.
the range?
Uh,
Range is different. Interquartile
It's
range is different.
Q's.
I did not attend the last class, but um,
Range is maximum minus minimum. So what is the maximum
yeah.
value here? 40. Okay. So
Hmm.
we ignore the outliers. These
Yeah,
dots
yeah.
are representing outliers. Okay. So we ignore the outliers. We don't take into account. Those are like one-off values kind of. So we ignore. So your maximum value is somewhere around some 40, 41, and minimum is probably around $7 or $8. So range here for Sunday is 40 minus 7, which is around $33. That's the range. Okay. What is the range for Saturday? 40 minus 2 or 3 maybe, so 37. So if you look at the bar graph, sorry, box plot here, the um, the Saturday has the highest variability. Okay, variability means people can spend less and more. Okay, so when you have higher variability, it is little difficult. Okay, to predict the actual expense. Okay, so people on Saturdays tend to vary. Okay, so if you see lower is also lowest compared to all the 4 days, higher is almost same as the higher of Sunday, right? People tend to spend generally less on Friday and Thursday. Saturday, Sunday, they tend to spend higher, but Saturday has a higher range. Priyanka, what are you doing? Okay, so let me. Okay, so what is interquartile range? Your Q3 minus Q1.
Yeah,
If you look at
Q3
a
minus
box
Q1.
plot, this is your Q0, lowest value. This is Q1, Q2 or median. This line that you see in
Q2.
the box is the median.
It's a Q2. Yeah.
Okay. So median, and this is your Q3, and this is your maximum value. Okay. So median, okay, is like average. So if you see on Sunday, people tend to spend more, right? We discussed the challenge of mean and average, right? So you see that on Sundays, people tend to spend higher compared to other days, and Fridays is on average less compared to Thursday or Saturday. Okay, okay. So now, okay, your we spoke about the histogram, right? Now, what you see here at 0 is your mean median mode. Now, assuming that data set is normal, okay, your mean median mode will be at the center. And okay, and let's adjust this to 0. Okay. Now, what you see down is the standard deviation. You know how to calculate standard deviation. You calculate the standard deviation, and when you plot a graph, okay, histogram, okay, in normal scenario, I'm saying if it is skewed, it will change. Normally, okay, okay, let's say your average is 0 and standard deviation is, let's say, 15. Okay, so from 0 to 15, okay, the area under the curve, let's say if you have total 100 numbers, okay, 0 to 15, okay, will have 34% of those numbers. That means 30, if you have 100, 34 numbers would lie between 0 and first standard deviation on one side, another 34 on other side. Okay, so between minus 15 to plus 15, okay, you will have 68% of the data set. Okay, as you go away, of course, it's going to decrease it. So we say that area under the curve for one standard deviation, which is -1 to +1, is about 68%. Okay, and this is fixed, so you can remember this is also called as 68. Okay, uh, 68, 95, 99.7 rule. Okay, 68.2 to be exact. Percent of data will be between -1 standard deviation to +1 standard deviation. Okay, and one standard deviation. This is what we call one standard deviation. On both the side, your variability is 1. Okay. Between two standard deviation, you have 13.6% more. So if you add all these four together, you get 95%. And when you go further away, 99.7 percentage of data will lie between -3 and 3. Okay. You'll have about 0.3, 0.1515, which is beyond 3 sigma. Okay. So generally up to 3 sigma means standard deviation. Okay, so up to 3 sigma, you will have 99.7% data set. So we can also use histogram to remove outliers. We generally consider, okay, data set within 3 sigma as as normal, and beyond 3 sigma as outlier. So most of the analysis we ignore data beyond 3 sigma. Okay. Okay. This here we're talking about accuracy versus precision. What is accuracy? Okay, accuracy comes from average. So I gave you this example, right? If I come at 5 and I come at 7, okay, average is 6. So if you take a dartboard, okay, and you are trying to, you know, obviously shoot at the dartboard, okay. Now if you are hitting consistently at the center, every time you're hitting consistently, okay, so average is what? Average is what you want. Where are you hitting? Where you wanted to hit. So what you're on average, you're meeting your goal on average. Okay, you're meeting a goal, that is called accuracy. Variability, it comes from precision. Precision, opposite of precision is variability. Okay, so precision means every time you are hitting there. Okay, that's precision. So okay, we are hitting at the center and we are hitting every time at the center. Okay, so it is your accurate as well as precise. Now here you see what is not accurate but precise. You are hitting consistently at one particular point. Okay, here. This is not what we want. This is not what we want, so it is inaccurate. But you're hitting every time at the same point. Variability is 0. Variability is 0, but that's not the expected value. Okay. So it's like this. If you run a car showroom, okay, and you are promising 15 days of delivery, but every time you deliver on 20th day. Every single time you deliver on 20th day. Okay, so it's not accurate. Okay, we want 15 to be the value, right? So process is not accurate, but process is consistent. Consistently you're doing that every time so there is more predictability in that process, less variability in the process. Standard deviation will be 0 if you deliver every day at on 20th day. The standard deviation is 0. Okay, so that means 100% accuracy. You can predict that on 20th date you will deliver, but inaccurate because we wanted 15 but we are getting 20th. It could be 10th also. Okay, so we call it as process is not accurate but precise. Accurate but not precise. So see, if you see this, okay, not precise means you are not hitting at the same point. Okay, sometime above, sometime below, sometime above, sometime below. So if you take average, you'll come to this point only. This is called as accurate but not precise. So, promising 15 days delivery. Once you deliver on 20th, second day you deliver on 10th. 20th, 10, 20th, 10. Every time you're delivering on 20th or 10, 20th or 10. So average is 15. So that's the average we want, correct? But you're not precise. You're not hitting at the same, you're hitting everywhere. So your process is accurate, okay? Because if you're Average is what you want. Okay, average is as per expectation. You say your process is accurate. Okay, so if I take class at my class time is 6 a.m., but let's say if I take class at 5 a.m. or 8 a.m. or 7, no, 7, right? Sorry, 5 a.m. or 7 a.m. Okay, so I'm not being consistent. So I'm not precise, but I'm accurate. Okay, because average is 6. One day, 1 hour late start, other day, 1 hour early start. So process is accurate. So we talk about process being accurate but not precise. Okay, and of course, not accurate, not precise is, you're not accurate or not even precise. Okay, so we want process to be both accurate and precise, right? But let's say, unfortunately, you have other three situations in your process. Which one do you think is easier to control? Not accurate, not precise, accurate, not precise, not accurate, precise. Which one do you think is easier to control? Generally,
Not
not,
not
sorry,
accurate. Yeah, not
not,
accurate and precise can.
yes, not accurate and precise can be easily handled comparatively. Okay. Okay. See, when
Yeah.
when when you are, constantly you're doing it, but it's not right. That means there is some process. There is somewhere there is a delay which is causing it. So if that's the case, okay, I need to, let's say if I'm constantly starting at 6:30, not at 6. Every day I'm starting at 6:30. So in that case, the process is inaccurate because average should be 6, not 6:30. But every time I'm starting at 6:30. So process, okay, is precise. So maybe I have to sleep half an hour early. If I sleep half an hour early, I'll be able to get up on time and take the class, right? But if process is not accurate and I mean not precise, then you don't know what to do. Sometimes it's early. See, when you see a trend, right? When you see a trend, you can focus on the trend. But sometimes it is early, sometimes it's late. So there's no fixed trend. How will you fix it? Worst thing is you move the median only. You move the, okay, the dartboard to that location, or you can say that, okay, update the time to 6:30, right? If nothing is working, so which is easier to handle. It is more easy to handle process which is precise, okay, but not accurate, than a process which is accurate but not precise. Okay, so that's why standard deviation has more important role to play. Okay, now, okay, let's look at this one. What do you see here? Okay, this is the delivery time, okay, taken by multiple fast food centers. QSR means fast food center, quick service restaurants. They are those, fast food centers which quick make sandwiches and pizzas and things like that. Okay, so if you take the standard delivery time, you have two set of, let's say, companies on the left side. So when you see the average is what is the average delivery time on the left side? What is the average delivery time on the left side?
It's 0.
It's 20 only.
20. Yes, it's 20, right? It's written 20, and your, normal, your hump is your median mode, right? So average time cannot be 20, 0, right? You cannot deliver in 0
Yeah, yeah.
seconds. Okay, then average 0 means there will be something on minus side also, left side also. So that means, delivering before you order, right? So you have delivery time 20 here, and the right side, okay, what is delivery time?
It's 30.
No, that's also 20.
0 point. How come?
20.
Look at the hump. Where's the hump?
The hump is exactly up to the 20.
Yes. So we discussed that, right? Mean median mode will be same in normal data set.
Yeah.
Mean
Okay.
median mode is same as the hump, right? In
Yeah.
normal,
Yeah.
and data is normal, right? It is symmetric. Okay, symmetric means it's normal, and in the
Okay.
both the cases, your mean is 20 minutes. Okay, that means on average they take 20 minutes to deliver your order. Okay, now what is difference between these two then? then what's the difference between these two graphs? The mean is same, then what is difference?
So the difference is in the variability in the data.
Correct. Okay, so which one has the higher variability?
The left-hand side graph,
The left hand side has
higher variability.
high variability. Yes. So you can see on the top it's written standard deviation is 10, right? So if you draw a graph with mean 20 and standard deviation 10, you get something like this, versus a graph which is mean 20 and standard deviation 5, you get something on the right side. So you see the right side has less variability, more consistency. So area within, okay, so if I take this to paint, okay, just a second. Sorry. So I told you here one standard deviation, one sigma. Here one sigma is 10, right? So this is your one sigma, right? And this side also it will be one sigma, 30, right? So that means what is the area? How many deliveries have been made within 30 minutes? Okay, sorry, not 30. This is your 10, right? Sorry, right? So how many deliveries were made between 10 to 30 minutes?
20.
68%.
Okay.
We just discussed that 68, 95, 99.7% rule. Remember 68, 95, 99, 68, 95, 99, 68, 95, 99. One standard deviation. Okay, both the side.
Okay.
So between 10 minutes to 30 minutes, between 10 minutes to 30 minutes, you are delivering 68% of the, okay, area is 68%. So, depending upon the business question. So it is delivery time. That means you have ordered 68% of the orders between 10 to 30 minutes. Now here variability is less, standard deviation is 5, right? Standard deviation is 5 means 1 sigma is what? 25 and 15. Okay, they take 10 to 30 minutes to deliver 68%. These people take, delivers between 15 to
15,
25
25.
minutes.
Yeah.
Okay, within these they deliver 68% of the order. Now, if you go to this level, let's say 10 and 30, that's what this graph is talking about. That means you're going up to 2 standard deviation. You're going up to 2 standard deviation, right? 25 and then plus 5, 30. Okay, 15 minus 10, 5, 10. So 2 standard deviation will be 2 times 5, 10, plus or minus 10. So plus 10 is 30, minus 10 is 10. So between 10 and 30, if you compare 10 and 30, they deliver only 68% of that order. But these fellow delivers 95%
95.
of the orders. Yes. They deliver 95% of the order within 10 to 30 minutes. Okay. So that's average is same, 20-20. Okay. But if you take the timeline within same timeline, they are able to deliver 68% of their order, but these guys are delivering 95% of their orders within this. Okay. So we say that they have a better process, more consistency. Now let's say if you are feeling hungry, right? You'd probably go here. See, both they have 20% average, but here you know that you will get your food. Let's assume 95%. Okay. Now you will get your food. Okay, between 10 to 30 minutes. Now, if you come here, if you take 95%, will be 2 standard deviation. Okay, 2 standard deviation means what you have to do? 20 minus twice 10. So between 0 to 40. Okay, on here you might have to wait for 40 minutes to get your order. Here you have to wait only for 30 minutes maximum. Okay, so that's the consistency, that's the difference between, or that's how you will be able to read your standard deviation. So this tells you the difference between their process. Okay, standard deviation will tell you the difference between their process. Higher the standard deviation, higher the variability. Okay, higher is inconsistency, higher is unpredictability. Okay, anyway, we are not talking about prediction in our course, we are talking only about the analytics. So it is higher, uh, 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 variability is higher. Okay, the range will become bigger the range. Okay, it's very difficult, right? If I tell you, oh, tomorrow we'll have class, we'll start somewhere between 6 and 7. So I'm giving you 1 hour range, right? So you want 1 hour range or you want 15 minutes range? 15 minutes, right? Higher the range is more error that can generate into the system, right? So this is what your standard deviation and mean tells you. Going back to from where we came. Okay, now let's look at this. Okay, you have some money and you want to invest. Okay, you have two options, investment A and investment B. So before you invest, what you do is you look at the returns that they have given. Okay, so this graph that you see is the returns this investment have given to you. Left side and right side. The left side you have investment A, right side is investment B. Okay, look at the x-axis and y-axis. Minus means minus return, right? People have lost money. So now you tell me, if you have money, which one will you invest in and why, of course? Come on. Make some guess. That's okay. You're in a class, right? Don't be afraid of getting it wrong. We're in a class. That's okay. But you think, thing is, after today, you should not make mistake. Today, you can make mistake.
I would go for investment A.
Why? Of course, why? The hint is both are right, okay? But question is why? Why is the main thing here?
Because it looks more symmetric to me. So
Symmetric means what?
no, not symmetric, but because both are normal, the data looks normal. But
No, it doesn't look normal to me.
oh, so it is the first one is positively skewed, a little bit
Correct.
positively skewed. Yeah.
Correct? So what does that mean? What does it mean for investment? So see here. Again, I'll take this to print and talk about it. Okay. So see here. What is the maximum value that investment A is giving? Maximum value A is giving is 75. And B is giving is also 75. Correct? So that part it is clear. Here if you see A minimum that is given is minus 30. But minimum here is your minus 40 also. Isn't it? So on average, okay, we don't know on average, but on the range you see, B is giving you minus 40 also, right? It's going beyond 40. But now if you see, okay, the value that it has given, in the negatives, it has more values here, you see, bars are higher. Though range is less, but there are more values here which are like from 6 to 10, right? Here you see, it's only 5, 5. Okay, and even if you take this one up to 0, it is what, 2. So 5 plus 5, 10 plus 2, 12%, right? So 12 returns, 12 times it has given you minus return. Here you see 6 plus 10, 16 times it has given. Okay, 16 times it has given minus return. But here only, you know, um, uh, single digit, right? Okay, 10 times or 9 times or 12 times maybe. But whenever you get, it is minus 40. Here it is only minus 30. Now, if you look at, okay, the highest is between 0 to 15, correct? So here also it is 0 to 15. That's fine. 0 to 15, there's nothing much to compare. Now, if you see here, between, okay, this is comparatively higher than this, right? Okay. So now you see, B is giving you, okay, maximum negative also, a maximum positive also. A is giving you negative and positive, but these are range is less. So if you are someone who doesn't want to take risk, you go with A. You don't want to take risk because you don't want to risk of losing 40%. But overall, you see, B is giving you higher value, higher the risk, higher the gain. So if you are a risk taker, you will go with B. There is chance of losing 40%, but there is high chance of winning also compared to this. Here you see, it is losing more money and we're getting less. But range is not going beyond 30%. The range is mostly around 15 to 20%. So if you are a risk taker, okay, for you, investment B might look better option. If you want somebody who doesn't want to take risk, okay, it's okay if I lose less, but I can't lose more. Okay, you'll prefer investment A. So there's nothing wrong or right. Okay, it's about your ability. So if you're older person, right, older age, like more than 50, 60%, probably investment A is better for you. But if you are young, 20, 30, maybe investment B might look better for you, right? So that's what it means. Okay, statistics is not about yes, no. If that was the case, then the B would stop selling its product, isn't it? Nobody would buy B if B is bad, or if A is bad, nobody would buy B. They would stop selling A. Okay? But it's about the right audience. Okay, they cater to different risk-taking investors. Make sense?
Yes, Swapnil.
Okay. So we have already discussed this, right? What is strong correlation, weak correlation? When you have a scatter plot, okay, and if the values are closer to a straight line that you can draw, okay, if you can draw a straight line representing the average values, okay, and if the dots are on closer to line, we say strong. If the dots are along the line, we say strong. That's where the word strong comes from. Positive is it's increasing. As you increase X, Y is also increasing. Okay, as you increase X, Y is also increasing. So positive correlation is because we are doing scatter plot. So here it is weak correlation, weak positive. Here it is strong negative. As X increases, Y decreases, right? So it is weak correlation. Here weak negative correlation. Moderate, okay, somewhere between weak and strong. And this is like everywhere. Dots are everywhere, right? Values are everywhere. So you cannot, if you draw also, you get a flat horizontal line, something like this. Flat, okay, which is parallel to your x-axis. So we say that, okay, no correlation. Okay. Then this is an example. Okay. So we'll not get into permutation combination. That is not for us. Okay. So with that, we complete our statistics. Okay. Now there are some, we'll take a couple of data set and we'll practice whatever we have learned. Okay. So to practice, we need to learn two additional data structures. We need to learn two additional data structures which are used to handle data from tables or table format. Okay, we have NumPy and pandas. Okay, from Python perspective, we need to know NumPy and pandas. So NumPy, okay, we'll start today NumPy, and hopefully we'll complete both NumPy and pandas tomorrow, and then we'll take a couple of examples, visualization examples to practice. Okay, NumPy represents data into two-dimensional format. Okay, two-dimensional format. So if you remember, you remember at least vaguely the matrices? Yes, no? Your maths class, matrices, do you
Yes,
remember
yes,
vaguely? Yes.
yes,
Yes.
yes.
So NumPy, okay, is a, you can say that it's a Python version of matrices, okay, where you can handle, m into n values, m rows and n column kind of, right? So
Got
if
it.
I declare,
Yeah.
okay, so to use NumPy, you have to import NumPy. So generally we say import NumPy as NP, okay? This is general way to represent it, okay? Now you will say, okay, and again, so do you remember range? We did range in loops. What does range 16 means? You cannot forget what you have done before. So we said range 16 would mean start from 0, go all the way up to 15. So range can take 3 values, 2 values, 1 value. 1 value means that's the ending value. Starting value is default 0, ending value is whatever that is given, and increment is
And then
1,
one.
right?
Yeah.
Increment is default 1, start is default 0. 2 values means you have start and end, default increment is 1. 3 values means you have start and an increment. Okay, so we ending values always up to start values inclusive. So we say 0 to 15. So we have 16 numbers. We can convert this into a matrix of format 4 by 4, right? So we have something called as reshape function of NumPy. NumPy is a module. It has a reshape function. So I'm going to, let's say, equate x equal to this, and then I'm going to reshape x. So I'm going to say x equal to numpy dot reshape. Okay, reshape. You give the value, so x itself, and then as a tuple, you give the rows and column. How many rows and how many columns you want. Now here it is 16 values, so 4 by 4 is the only option that you have, or 8 by 2, or 2 by 8, right? So let's do 4 by 4. Okay. Now when you print x, okay, you see, you get a matrix structure. You get a matrix structure. Okay, we don't want to focus. Yeah, so from data analysis perspective, you need to know NumPy and pandas. Okay, these are the two additional things. See, what we have done so far in Python is core Python. Okay, core Python, that is for every kind of work, whether you're doing web framework, whether you're doing analysis, data science, whatever you do, that is the base thing that you have to know that much. Now what we are doing is we are learning topic. Very Python is very vast language. Okay, it has a lot of libraries and you can do almost anything and everything. Okay, in Python. So of course we are now going towards data analysis side. To perform data analysis, you need to be good with NumPy and Pandas libraries. Okay, Okay, we'll see that. Okay, those are the libraries that we use for manipulating or editing or data. Okay, you might get a data and data may not be clean. You might have to remove, add, perform some basic statistics on those. Okay, so that's what we will learn. Okay, in next maybe by tomorrow. I'm looking to finish both NumPy and pandas. Okay, so print X. Okay, and so you get a matrix format. Okay, it is always first is row then column. When I say 4 comma 4, it means row comma column, right? So here anyway 4 and 4, so both are same. But if I make this as 8 and 2, okay, if I make 8 and 4, then what happens? Okay, you get error. Why? It says you have given me 16 values, but you want me to reshape into 34. How is that possible? 8 comma 4 means 34 values, right? 8 rows and 4 columns. So 8 rows and 4 columns, I want 32 values. So you're saying you gave me 16 and you're asking me to make 32 pieces. Not possible. If you give me 16, I can only make 16 pieces. So that's the error. So we can say 8 comma 2. 8 comma 2 would mean 8 rows and 2 columns. So you have 8 rows. Okay, horizontal is rows and then 2 columns. You can say 2 comma 8. 2 comma 8. Okay, we'll have 2 rows,
2 rows, 8
8
columns.
columns. Okay, but here in this case, let's take 4 by 4. This looks better than 2 by 8 or 8 by 2. Okay, so this is your NumPy. Now, how do we do indexing of NumPy? Okay, so indexing, I told you when we were doing indexing, remember for which all things did we do indexing? So indexing is reading
For
data.
list,
Correct. List,
for
string.
strings,
So what
for
did we use? Which sign or what did we use to perform indexing?
that was the square bracket.
Correct. Okay. So yes. So when you have more than one value, right? If you say a equal to 5, there is no need to do indexing because a has only 5 only. You cannot say, oh, tell me what you have, right? Because it has only one value. Okay. But when you come to data structure, collections means storing more than one value in a variable. So here you see we have x, which is one variable, and it has more than one value. We have 16 values in it. So this is where we need to use indexing. And if I want, okay, okay, so here also we have to use square bracket. Okay, but now NumPy is different than your list, tuple, set, and dictionary. Those were all one dimensional. Okay, here all these are two dimensional. Okay, even if I say 0 by 0, it is 0 element, but it is structure is 0 by 0, two dimensional. Okay, so when you have two dimensional, so you have to do little different, isn't it? So it doesn't need just one set of values, right? List and string, and we saw we just say 0 comma 5 or 0 colon 5. 0 colon 5 means 0 from 0 go up to 5. But here you have to indicate both x-axis and y-axis, right? Yeah, I have to say, okay, from here till here, and also from top to bottom also have to tell you, isn't it? So here you will use x, I mean square bracket, and you give comma in between. Okay, comma. Left of comma is rows. Okay, right of comma is column. Okay, now the concept is exactly same as the one we did in list or tuple. Okay, so it's like you have a vertical and horizontal two list. Okay, in one program, okay, in one program you are handling two lists. It's like that. Okay, so left of colon comma is your rows and right of comma is your columns. Correct? Okay, now left of comma, what should I do here? Okay, first let's decide what we want to print. Let's say I want to print 4, 5, 6, 8, 9, 10. Okay, 4, 5, 6, 8, 9, 10. This is what I want to print. Okay, so left side is rows. Okay, so which rows are we printing? Which rows are we printing? Okay, forget about indexing. First, you tell me, looking at the shaded part, which rows are we printing?
Mm.
Second and third.
Second, third, yeah.
Second and third, right? So what is the index of 2? I mean, what is the index when I want second value? So index of that second row is 1, right?
1. Yeah.
Yes. So 1, and then from 1 I have to go up to 3. Remember, the up to is, I mean, this is up to, right? If I say 1:3, that means I'm doing 1 and 2. Yes or no? 1:3 means I want 1 and 2,
1 and 2, yeah.
right? Similarly, on the right side, I want which are columns? I want 0, 1, and 2. 0, 1, and 2.
0 to 2.
No,
Yeah,
0 to
0.
3.
Okay.
All ending is always 1 before, isn't it? So I want 0,
Okay.
1, and 2. So if I want 0, 1, and 2, I have
Sure,
to
sure.
say 3.
0 to 3.
Correct.
Yeah.
And you don't have to give 0, right? You don't have to write extra. We know that if you don't give value on the left, it is 0. When you don't give value on the right, it is up to last. Correct?
Last one. Yeah.
Yes.
Okay.
And then you print and see, do we get 4, 5, 6, 8, 9, 10? 4, 5, 6, 8, 9, 10. Okay. So this is how you can do indexing on NumPy. Okay.
Yes, okay.
Okay. So you can perform here addition, subtraction, multiplication of two because it's a matrix, right? So matrix has addition, subtraction. So let's say I define two matrix. So here I'm going to say, okay. So you have x, and let me say I say y. Y equal to, let me again create a range, and I'll say 11, comma, okay, uh, 27. Will this give me 16 values? Okay, let's see. Okay, so I'm going to say y equal to, and let me print y. Right? So yes, we got 4 by 4. Now I can do x plus y. X plus y will add two matrices. Small y. Okay, so this is addition of two matrices. Okay, so so you can do um, um, you have plus, okay, you have minus, you have multiplication, x plus y, x minus y, x into, okay, I'm going to tell you. This is a, okay, so this is your x plus, this is your x minus. Easy to understand. Okay, division easy to understand. You're dividing each element from 0th. See, each element has an index. So what is the index of this? 0, 0. 0 row, 0 column. What is the index of 14? What is the index of 14? Position of 14.
Can second row, fourth column.
Yes, what is the index? Second row is what? 1. Isn't it? First is 0, second is 1. So it is 1,
Okay.
comma
1.
1,
1 comma
comma
1, 3, 4. 1 comma 3.
yes, 1, comma 3. Yes. 0,
Yeah.
1, 2, 3. Fourth column is 3,
Fourth position.
right?
Okay.
So 1, comma 3 is the correct. That's the index of 14. Okay. So it will take, when you say plus, it will take 0, 0, add to 0, 0. Take 1, 0, add to 1, 0. Take 2, 0, add to 2, 0. Okay, same number of element will be added or subtracted, okay, or divided. Multiplication, if you do, it will do the same normal multiplication. But again, if you remember from your maths class, that's not how we perform matrix multiplication. Okay, matrix multiplication is
Okay.
little different, where you multiply first, okay, uh, column of left side into first column of right side, right? That's how we used to perform multiplication. So that multiplication is done using at the rate sign. Okay, at the rate
Yeah.
sign, okay, is a matrix multiplication. Normal multiplication is this, you'll just simply add the elements. It's called element multiplication. But this is your matrix multiplication.
Matrix. Okay.
And this is your element.
Element multiplication.
Okay, so you get this. Okay, so this is normal, okay, NumPy, okay. It has its own advantages, right? But our intention of learning NumPy is to actually learn pandas. Okay, so pandas is actually way to handle a data into table and column format. See, whenever you get a data, okay, the structured data I'm talking about, not video, audio files or text files. Okay, so we'll do one exercise on the text file also. Um, uh, but if
Okay.
you look at structured data, okay, you will get mostly in table and column, whether you take CSV file, whether you take Excel, whether you take database, right? Excel, database, CSV, all of these are like table and row format. So data frame, okay, which is the type of data, okay, is the which has row and column. Okay, it has row and column. Okay, so that's
Okay.
the advanced level of next level of NumPy. So we learn NumPy only to go and learn pandas. Okay, and
Okay.
you can take one example and show you here. Okay, let's say, um, okay, let's take an example here before we end the day. Okay, so let's say I create a, I want to create a table. So I want to create, let's say, fruit production kind of thing. Okay, uh, okay, I'm just thinking, okay, how the data should look like. Okay, so data, okay, I will give list. Okay, yeah, should be okay. Now I'm telling the first column is the value, sorry, the name of production, like, Apple production. Now I'm going to say that in 2022 first quarter, I produced so many kgs or quintal, whatever you call it. Okay, so there are 4 quarters, right? So okay, now here I'm going to say, okay, I can put it in different line. I'll say oranges, let's say oranges. Okay, I'm going to put banana, and let's say I put mangoes. Okay, so here I put 1 1 1 1 3 3 3 3 2 2 2 2 4 4 4 4. Okay, here I put something like 1 3 2 5 6. Here I put 500, 900, 300, and 400. Okay, so now if you see, this is just a list, right? So if I print data, okay, you get a list value. This is not a table. I need to convert into table format so that I can perform all my statistics like NumPy, sorry, mean, median, mode, and things like that. Okay, so we have a function. Okay, we
Okay.
have to import pandas. So I'm going to say import pandas as PD. Okay, now Pandas has a function pd dot data frame, D capital F capital, data frame. So data frame is the table equivalent in Python. Table equivalent is Python. In Python is your data frame. So I'm saying convert this data into Python data frame. So I'm saying pd.data frame and bracket you say data. Now I can say data df, generate data frame. Okay, so since I've converted to df, I'm going to say data underscore df. And now when you print data df, okay, so you see, oops, yeah, here you see it has created this table for you. We have not given the column headers and we have not given the row numbers, right? So Python will automatically add column header and row header. Every value is accounted for. So if you say, since we did not give the column, okay, it has given first column as index 0, right? So that's what. So if I ask you what is 3 comma 3, what is the 3 comma 3? What is 3 comma 3?
It's banana 7 6.
No, 3 comma 3 is this one, right? So it is
Okay,
mangoes,
photos. Yeah.
right? Photos. Now,
Mangoes for photos.
yes. Now I can give, okay, I can give headers. Okay, so headers also I can declare um, uh, as a list, okay, as a list. So I'm going to say fruit, okay, and Q1 2022, Q2 2022, Q3 2022, Q4 2022, right? So this is the header which I want to add. Okay, so when you're forming data frame, okay, here you can say comma columns. Okay, I don't know, columns, columns. No, here I'm printing, right? Sorry, not here. The where you are creating data frame here. Okay, so you say columns equal to headers. Now when you run it, you see it has added the header fruit Q4, right? Now
Yeah.
you can add to the row labels also. Okay, you can add row labels. Row labels are called as index. Okay, so index equal to, I can say fruit 1, okay, fruit 2. Mostly we'll be dealing with very large tables, so there we cannot give names to all the 1,000 rows, right? So generally rows will not have names, rows will have numbers only, columns will have header. But just to show you that you can even name a row. Okay, so fruit 2, fruit 3, okay, fruit 4. Okay, and then you say here, comma, index equal to index. Oops. Okay, this is the previous one because we are doing 0 by 0, right? That's why it's getting error. Okay, this one is creating that error. Okay, fine. So you see, the row has been named, column has been named. Column will be named using column, and the rows are named using index. Okay,
Yeah.
so this is how we create a table. So yeah, tomorrow when we meet, we will talk about reading data from various sources and will perform certain operation on them. Okay, any question before we end it?
No, sir. All good.
Okay, great. So sure, we'll see you tomorrow, same time. Yeah.
Sure. So tomorrow is the last day for statistics?
Statistics is done already. Today was the last day.
Yeah, yeah. Okay.
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 So we are doing, we'll use Python to visualize the data. Okay. So that will
Okay.
take 2 more days. 2-3 days. Okay?
Okay.
Yeah.
Yeah. Daddy. Thank you. Thank you.
Thank you. Bye.